Hello and welcome to the basic Git command tutorials. This first lecture is going to be how to use Git on the command line and just a list of useful commands that you can use in Git. The next video will be how to use this in Xcode. So this is more of a reference of how the commands work and what they look like on the command line, and then we'll go into how to use it in Xcode. To get started, if you haven't used Git before, Git is a version control system, which means it tracks and saves the state of the files every time you uh, commit to Git. You can use this with anything. It doesn't have to necessarily be code. Um, Another thing you can do is also text documents or art. Git just happens to be the most popular version control system for software developers, but there are other options out there. They're pretty interchangeable. There are differences, but if you learn one, you should be able to use another. So all of our assignments will be submitted using Git after the first couple days, and hopefully within the first lecture we should have you uh, using at least the basic commands. You won't necessarily use all of the commands I present here, but let's go ahead and get started. The first command is, of course, to start a new repository. So you'll do a git init, as you can see in the first terminal there, and that just generates uh, an empty Git repository. The repo, or repository, is just a folder that you normally can't see. It's just a .git folder, and this is where Git stores all of its internal tracking data. The directory you run the git init command in is referred to the working directory, and I referred to that several times throughout this slideshow. Throughout this presentation, you'll see some bolded words. We may use those in a quiz later on, so if I don't explain it thoroughly here, go ahead and try to look it up on your own and get a good definition. The other option, instead of using git init, is to use a git clone. Git clone pulls from a repo already on a remote source, so like GitHub. Git and GitHub are two different things. GitHub is just a website that is a place to store documents and things for people that are using Git. Here you can see that I used git clone on a example Git repo, and in the first line it's just running the command. The second terminal box, you can see it clones and it goes through some operations, and then it tells you that the unpacking objects is 100% done. Typically it doesn't take too long. On a larger repo it takes longer, but fairly simple. Um, the address here is the remote origin, and there's a few ways to refer to it: remote or upstream. Through most of this I refer to it as remote. Inside of the directory you can now see the .git folder. So if you just do a simple ls to see what's in this folder that you did the git clone, it gives you a new directory that should match the repo name. And then if you change into that directory, you can see the file that's there, which is only the README, and then the .git that comes with it. Git status prints the current differences between the latest snapshot and the current state of the directory. So anything you've done between the last save and now will show the difference here. And Git status is also useful if you're merging or doing some of the other things where something's not been saved or there's issues. Uh, Git status typically will tell you what's going on and show you what's different between the last time uh, you did a git commit and where you're currently at. With the examples here, um, a git status just shows that nothing has changed and the working tree is clean. And then on the second one, I went ahead and changed the README file. And then in the README file, I added a line of text. And so now it says that the README file has been updated or been modified, as you can see in the red text there. And so then you would do one of the following commands. I believe I jump into git add next. Oh, git branch. Um, okay, so we'll come back to how to add later, but uh, so Git works on a tree structure. When you make your first commit, it creates the head node that you're currently at, and um, you can continue just committing in a straight line, and you'll have a very linear tree. However, if you want to work on something different and you don't want to have it in your main, change your main branch of the tree, you branch out, and typically you're going to do that every time you start something new. Especially if you're working in teams, you're going to start a branch because you don't want to change the main working folder. Um, if your code's already running 100% and some of the functionality is functional and there's no errors, you want that main branch to stay useful. And so you branch out and start writing your tests, or you start writing your features. Um, Typically, you'll have 3 branches: a master, a DevOps, and then if you're ready for release, you'll have a release branch. And we'll go into some of that later or in a second video. Um, Another option, so git branch allows you to create a new branch. So you do a git branch and then you name the branch whatever you want. For this, I just created a branch called add new file, and at some point I add a new file and to this branch and then delete it to show some of the other things you can do. Um, but if you do git branch minus minus list, you'll see the full list of branches you have for that repo. And the star and the darker text on master in this example show that that's the current working directory and the current branch you're on. So once you've created a branch, you can do git checkout and use that same branch that you've just created, and it'll switch you to the branch. Another thing you could do is use the B flag, and with that you do git checkout B, and then you get new temp branch. And this will switch to the new branch at the same time it creates it. So if we go back to the git status, this is where git add comes in. And what git add will do is after you finish modifying a file, you can use git add and it'll stage it to be ready to commit. And you do this when you're done with a feature or a segment of code that you're sure works 100%. You go ahead and stage it, and you'll make a commit. But first I'm going to show you how to git remove. Git remove will remove a file from your working directory. So back to that add new file branch, I created a new file called new temp file, and then I committed it and saved it. And so Git thinks there's a file in the repo that's called new temp file. And if you see in the first line where I did an ls, new temp file exists. The second line I remove the new temp file, and then I do a git status to see what Git thinks about that. Well, Git still thinks that new temp file exists, but it sees that it no longer is in the directory. So it says, hey, you deleted this file, is that what you wanted to do? And what you can do is the git rm, which is git remove, and it'll remove that file from the working directory. So you can see that after I do git rm, um, it, the git status now shows that you have a new temp file that is deleted, and instead of appearing red, it appears green, and that's ready to commit. So git commit is what saves any changes you have staged. So anything you've added or removed with git add or git remove allows you to save it with a git commit. Anything that's not been added or removed will not be saved in the git commit. So make sure you're adding and removing files before you do your git commit. Um, if you just do git commit, it'll pop up a text editor, typically VI or Vim, and uh, you'll have to write a message there. If you use the -m flag, it allows you to write a short commit message, and typically you want those to be rather short, and depending on your team, some teams say to write in the imperative. Um, so far, as long as there's something there that's descriptive of what you've changed in the commit, it should be good. At least until you get, on a more formal team. If you want to check out the differences between where you're currently at or two different branches, you can use git diff. What this is going to show you is any changes that have been saved to one branch over another. If you look at, for this example, we used the add new file and the new temp branch, and in one, the README only has 2 lines in it, and the other, the README has 3 lines in it. This one, it shows that the add new file only has the first 2 lines, and then the new temp branch has 3 lines, and you can see that in the example it does the first line I wrote git diff add new file and then new temp branch, and then it runs and it says A is readme.md and B is readme. So they're the same file. A is your first called branch in that command, and B is your second branch in that command. So in the A readme, it would mark anything that you've removed with minuses, and in the B readme, anything you've added with pluses. And so the only thing we did was add a line, and so it shows a new empty line, then a new line with a plus in front of it. Pretty simple, pretty straightforward. I don't find myself using git diff that much with simple changes like this, but there's more useful interfaces that you can see these kind of differences and understand basically this style later on when you use GitHub or GitKraken, things like that. You can see the differences between one commit and another, or one branch and another. So the reason you'd want to see the differences between 2 branches is if you're going to merge the branches. And if you use git merge, you can merge between whatever branch you're on and whatever branch you call. So for this I did a git branch list, so you can see all 3 branches in this repo. And then I merged, while I was in the add new file branch, I merged new temp branch onto the add new file. Well, it merged it into, so the changes are now in new temp branch, or they're now in add new file. And I believe this also pops up for a message because it commits as well. So you can also use the M flag like you did in the git commit to leave your commit message as well. So back to the remote directory, you can use git remote to change or set your upstream location or your remote origin location. If you use -v, which stands for verbose, you can see information related to the get remote command. And when we use it just get remote -v, you get that the current place it's connected to with origin is the directory clone example.get, and that's where you're going to fetch from and push to. And if you did a get remote add, you can add a new origin, or you can add a new upstream, or you can call it whatever you like. Typically, you're going to call it origin, and you can set the repo you'd like to set. This one I placed this in a new folder, or in the original get example folder. So now I have two repos here that we've been bouncing between. So once you have a remote repo that you're going to pull from or push to, you can use git push to copy everything that's currently in your repo and send it to the remote. And it's going to set whatever branch you're on upstream. Now the first time you do this, you have to set up your branch to the upstream location. So you're going to use the -u flag to set the upstream branch, and you can see that in the, I think I did it in the first box. Yeah, so on the first line there, in the first terminal, you can see git push origin master. And then if you follow that down, I was getting a weird error about credentials. Most of the time, the only thing I look for here is that you had a successful master to master push, and that it set up the remote track for the branch. And in the second box, I kind of do the same thing, except with the add new file branch on the clone example repo. And this time, you'll see at the bottom, a couple lines from the bottom, it created a new branch, add new file, which is called add new file, and in branch add new file set up the remote track from origin. Pretty simple. Git fetch checks the remote repo for any changes compared to your local repo. So if you do a git fetch, it pulls down all the information to the git.git folder and it saves it there. And it says that the upstream has differences, or it's the same. And if you do a git status, it'll tell you what's going on. And then git diff will show you if there's any differences. And then I'm not sure what I did. Oh, on this one, if you the git status in the terminal box, which is a few lines down right after the git fetch completes, it says on branch master, your branch is behind origin master by 2 commits, and you can be fast forwarded. So what this is saying is that the remote has a couple changes that the local does not. And so what we want to do next is a git pull to pull those changes to your local repo. Now nothing's changed in the local since the last time it had an update from remote, or remote had an update from it, but the remote changed since, and so the remote needs to send that information to your branch. So you do that with git pull. Git pull is going to retrieve the head of the upstream repo and merge it into the working directory. Be careful if you've made changes on your local directory. You will need to manage any issues. Git log is useful to see all of the commit history. There's a few extra flags and stuff that you can use with this. I don't use it that often, but if you need to go and revert back to a previous state, you'll want to look up the commit history. And a lot of the repo that I've been using for this example, the only thing in there is README, and I've just been updating the README. So you can see where it says update readme.md is basically just the um, commit message for all of those, and then there's the initial commit message at the very start. You can think of all of those as your linear tree on your master branch, and that's without any of the branches commits. That's just what's been happening in the master branch there. Get revert is what's going to allow you to choose one of those commit messages to go back to. It allows you to go back to a previous version. It kind of unwinds what you've done. And if you use head or head tilde and some number, like in the example I used head tilde 2, it's going to revert back 1 or 1 plus however many you specify number of commits, and reset it back to the code that was at that location. And then it's going to add a new commit to the start, or to the top of your linear branch there, so you can see everything that you've done. There's a couple other ways to go back to previous commits. Personally, I feel this is the safest way if you want to keep track of all the changes you have made. But everybody has their preference with using Git, so there's a lot of other things you can do with Git. This was just kind of the basic overview. We're going to go more in depth in the next video on how to use some of the stuff in Xcode, and I know it's a lot to retain, so don't worry about memorizing it all. I would definitely get some of this information down on paper. We'll use some of this in class, but mostly it was just to kind of introduce you to the topics and have you ready to go. Alright, thanks for watching. There's a lot of further resources in the comments. There's a cheat sheet that Git provides, as well as the official documentation. So check those out.